Let's discuss the energy transitions occurring in the Venturi meter. Because energy must be conserved, the total energy of the Venturi system and its surroundings remains constant when fluid is flowing through the Venturi. However, that total value is a sum of different forms of energy, and energy can be converted between the different forms as fluid moves through the system. One example of an energy transition is a ball rolling down a hill. At the top of the hill, when the ball is not moving, it has high potential energy due to its height, but no kinetic energy because its velocity is zero. As the ball accelerates and reaches the bottom of the hill, the potential energy is converted to kinetic energy. Energy transitions also occur when considering the Venturi meter as a system with fluid flowing through it. To understand this, let's think about the velocity and pressure at different points in the Venturi. At the Venturi inlet, the velocity is low and the pressure is high relative to the corresponding values at the throat for these two terms. Because of this, there is low kinetic energy and a large amount of flow work or flow energy to push the fluid into the Venturi. Remember that flow work per unit mass is calculated as pressure times specific volume. As the fluid moves towards the throat of the Venturi, the velocity increases due to the shrinking diameter and the fact that mass must be conserved. This increases the kinetic energy. To compensate, the flow work term must also decrease. If we assume the fluid is incompressible, then the specific volume remains constant and the pressure must decrease. In other words, as velocity increases, flow work is converted to kinetic energy. As the fluid moves away from the throat towards the outlet, velocity slows and kinetic energy is converted back to flow work as the pressure increases. However, some energy is also converted to thermal energy due to friction as the fluid contacts the wall of the Venturi. That energy is lost to the surroundings, and therefore the outlet pressure is not fully recovered to the inlet pressure. However, the velocity at the inlet and outlet is the same because of conservation of mass. In summary, the total amount of energy of the Venturi system and its surroundings remains constant as fluid flows from the inlet to the outlet, but the dominant form of energy changes from the inlet to the throat to the outlet. Thermal energy losses to the surroundings because of friction does not allow full recovery of the flow work, and therefore pressure at the outlet is less than at the inlet.